A very good morning to everyone. I'm Chen Long, your MC for today. First of all, on behalf of University Malaya, I would like to extend a very warm welcome to all of you. We appreciate you taking time off your busy schedules to participate in this inaugural lecture today, which will be delivered by my beloved supervisor, Professor IR Dado Dr. Roslan Hashim from the Department of Civil Engineering. The lecture will begin shortly. For your information, this inaugural lecture is organized for professors in UM to share their knowledge and experience in their respective expertise. In addition to that, it also complements the promotional process and the service extensions for professors in UM. Ladies and gentlemen, please rise. Announcing the arrival of Professor IR Dr. Abdul Aziz Abdul Rahman, the Deputy Dean Faculty of Engineering, University of Malaya, who will chair this morning's lecture, and the Professor IR Dado Dr. Roslan Hashim, the speaker of today's lecture.
University Malaya, kebanggaan kita semua, bertambah para ilmuwan di berbagai lapangan. Kami bertekad di hati mencapai cita murni, tradisi kecemerlangan menepati wawasan. Di sini kami sedia berbakti, terus berinovasi. Kami harapkan generasi muda, teras nusa dan bangsa. Varsity kesayanganku, sungguh banyak jasamu membentuk insan mulia, berilmu berbudaya. Di sini kami sedia berbakti, terus berinovasi. Kami harapkan generasi muda, teras nusa dan bangsa. Varsity kesayanganku, sungguh banyak jasamu membentuk insan mulia, berilmu berbudaya.
Good morning, Professor IR Dr. Abdul Aziz Abdul Rahman, the Deputy Dean Faculty of Engineering, Professor IR Dado Dr. Roslan Hashim, Management of the Faculty of Engineering, University of Malaya, and ladies and gentlemen, Welcome to the inaugural lecture by Professor IR Dato Dr. Roslan Hashim, entitled Integration of Hard and Soft Engineering for Coastal Rehabilitation. Without further delay, I would like to invite Professor IR Dr. Abdul Aziz to chair the lecture and introduce Professor IR Dato Dr. Roslan Hashim.
Okay. Assalamualaikum and good morning. Selamat berpuasa. Thanks for being here. Okay, Dato Roslan Hashim, my good friend. I've known him for more than 25 years. I think when I was a student here, he's already a tutor here. That's how long I know him. And I know that he has got not many many of us have more kids than him, I think. Is that true, Dato? So now Roslan Hashim was appointed as a professor of geotechnical engineering at the University of Malaya in 2009, a long time ago. And he is the head of coastal processes studies and coastal engineering at Institute of Ocean and Earth Sciences, University of Malaya. He's also one of the directors of University of Malaya Consultancy Unit, UPOM. He sits with me. I'm a fellow director as well. And I have seen him. He contributes a lot for consultancy unit. He has done a lot of consultancy work. And of course, UPOM, we know it's a multidisciplinary consultancy company registered under the Board of Engineers Malaysia. And it started in 1992. And he was also the head of Civil Engineering Department, Faculty of Engineering at University of Malaya between 2007 and 2009, and between September 2009 and June 2011. During this time, Civil Engineering Department went through a big expansion in terms of facilities and things like that, I remember. In 1983, after graduating from Leeds University in Civil Engineering, he joined Department of Civil Engineering at University of Malaya. 1 year later, he returned to UK to pursue his PhD on a title Time-Dependent Cavity Expansion in Normally Consolidated Clay Soils. I was told this is one of the advanced area at the time. His early involvement with problematic soft soils began at the time, and in 1989 he was awarded a PhD degree from Sheffield University, and he joined University of Malaya immediately after that. Throughout his career, he has specialized primarily in construction on soft soil grounds, providing advice on numerous projects involving ground improvement methods, earth-filled dams, organic soft soils, and design of foundation. In addition, he has been responsible for introduction of innovative integrated coastal protection measure under the umbrella of ecological engineering. And in 2012, he was appointed as the principal investigator for one of the high-impact research project. Now, the development program was successful in rehabilitating degraded coastal ecosystem in number of pilot projects at West Peninsula, Malaysia. So he has been through and through a civil engineer, rehabilitation of coastal lines. He has been a member of Institute of Engineers for a long time, since 1998. He obtained his professional engineer status in 1999, and currently the member of American Society of Civil Engineers and fellow member of Engineers Australia, quite prestigious fellow. He was also the member of Commission of Inquiry into the failure of certain civil structures in the state of Penang. And for that contribution, he received his award, Darjah Setia Pangku Negeri, DSPN, that carries the title Dato' from Penang government. Well, he made history too. Dato' Roslan is the first ever Dato' from this faculty while serving. For the last 50 years or so, while serving is the first ever Dato'. So that's actually a very good achievement. And Prof. Engineer Dato' Roslan Hashim has taught undergraduate and graduate level courses in soil mechanics, coastal geotechnics, geotechnical engineering, and foundation engineering. Currently, we are teaching this law we are teaching moral and ethics course together. It's a pleasure for me to teach this subject with him. Erosion is also involved. His main research team is soft soil improvement, erosion mitigation and prevention, field of characterization of soil, field testing and monitoring groundwater, seepage and permeability, and eco-friendly coastal protection structures. He has supervised more than 30 PhD and master students and published in numerous high-impact papers, books, engineering guidelines, and conference papers. So we have a man that achieved a lot in his life, and I'm sure today he has got a lot of things to tell us, a lot of things to share with us in a short humbly. Therefore, I invite Dato to deliver his inaugural lecture. And before that, let us give him a very warm welcome by giving a big clap of hands.
Assalamualaikum and a very good morning to everyone. And I would like to thank you for coming to this event, because I think it will help a lot in terms of, for me to go forward. There's not much time for me to go forward here, but I think whatever that I can get here will be good for me, and hopefully I can continue to contribute for this faculty as well as UM in general. And today I will be talking about integration of hard and soft engineering for coastal rehabilitation. So basically, in my working life here, I've been involved in several work. Initially, more on geotechnical engineering. Later on, I go on to go into coastal engineering, and lately I've been going into ocean, energy, and so on, mainly due to my interest as well as due to circumstances beyond my control. Sometimes I was given things which I have to do, and somehow I have to do that. And today I'll be talking about one of the research that we have been going through, and basically related to coastal rehabilitation. Okay. So basically, we are talking about this particular work and this particular presentation relate to coastal processes, relate to coastal events, where, as we know, that our coastline is being hit by wave action as well as other positive or negative forces, and for that matter, resources along this coastline will somehow be affected. So, if you go through some of the write-up or publication, you will know that several stretches of our coastline is under threat of erosion, and from there, our coastal vegetation will be affected, as well as our coastal population, because whatever happened in negative way will somehow be transferred to the people. So basically, this particular work that I will be presenting here relate to sustainable coastal management, where we wish to introduce, or we are introducing, a mixture of hard and soft approach. Hard, here we are talking about the hardcore engineering approach. Soft, here we are talking about making use of available natural resources. So basically, I'm talking about area that we can see in many parts of our country along the coastline, where we have eroded coastline, as well as if I talk about vegetation, we have a lot of mangroves before, but many parts of that has been destroyed because of development or cutting of all these trees for firewood or for other purposes, sometimes for construction. Secondly, the forces of nature, where waves and wind action somehow help to worsen this particular problem. So if we look into a simple graphic, we will see that, we'll see that on the left is our agricultural land, and then on the right is the sea. So basically, a simple approach will be to build a bund to separate the two areas of economic importance, right? So basically, our project, or what I'll be presenting today, relate to this particular issues or problem. And here we are introducing two different kind of approach. In the old days, if the problem is given to an engineer, basically they will go for the hard engineering approach or approaches. For example, they will build a wall, a revetment, or anything that will physically block the threat of waves and wave energy. And this is good for one thing. It will protect this, that particular area under threat against these forces. However, that approach is open to a negative impact of destruction to vegetation, or it will not be suitable for the coastal plants to survive. So basically, what we are doing and what is available is what we call self-engineering techniques, where incorporation of this technique is being introduced, such as beach nourishment, planting of stabilization of sediment dunes, mangrove and wetlands. So basically, what we are presenting here is the approach where we have that particular problematic area, where we introduce, for example, here, for example, in the diagram on the bottom of that photos, where we introduce restoration area with a breakwater, which is an engineering approach. We plant suitable species of vegetation. For example, here we are talking about mangroves, and then that will be a barrier. The restoration area will be a barrier against wave and other negative impact that can, harm agricultural land. So basically, this is what we are saying here. The dike or the breakwater is the hard solution, hard engineering approach, and we introduce soft option, that is, we plant mangroves or suitable species, so that the two will be protecting the agricultural land or villages and so on, and at the same time it is naturally formed because of the introduction of the suitable plant species. So that is basically the main crux of this particular presentation, where we talk about integrated approach to coastal management, which is in contrast to what has been used if the problem is given to an engineer. That is, a typical engineer will straight away go to the hard solution, and that will solve the problem. But basically, with that solution, we will have something like what you see here. There is something solid structure being constructed, and you will see that you'll see that it is safe, and yet it is not something that we like to see, we like to have within our area. That is a hard thing. So this is another example where we have detached rubble mount breakwaters introduced, and if that is the solution, then it will help the protected area against the force of nature, waves, and so on, but it will remain as it is. This is just an example, right? So basically, this particular populated area is exposed to wave and wind action. So what they have is to introduce structures measures basically to protect the slope and the land from waves and so on, right? So basically, this is such an action. So basically, when we talk about integration of hard and soft approach, we are talking about those hard engineering alone will help solve the problem of erosion and so on, but it will be quite dry and quite a solution which is not suitable for human daily or daily life as well as continuing their life there. So basically, these are some of the example of the solution and the problem. So if you look at, if you look at the photograph or the sketches, you have on the left hand side the sea, and top of that dike will be the structure, and basically this is what you can say is, if you give the problem to a typical engineer, this is what they will do. That is, they will introduce structures as well as they will redo the landscape so that they can address the issue of wave action. That's it, or that will be the solution. And this will not be acceptable for most people, right? And on top of that, if we have a disturbed or already an area where it is already disturbed and spoiled, so it is something which is difficult to do. For example, we can introduce on the left, we can introduce a structure, but then it will be just to minimize the impact of waves, but just like that. So basically, what we are proposing, and we have introduced that in several areas, that is the integration of hard protective structures and the introduction of suitable plant species, meaning to say we are talking about hard and soft approach for any kind of area or site that have similar problem. It means that the way we see the problem, the whole approach of introducing hard structure is not okay for today. So basically, what we will be talking about later will be on why or how we do that, right? We have several projects, but we will just be looking into one particular project, that is Sungai Haji Durrani in Kuala Selangor. Right. So basically, this is if we use Google Map, we Google Earth, we'll see part of it is something like this, right? So you can see that other than the farm, the area used to be filled up with mangrove, and what we can see is that the shoreline is eroding. So it has to be protected. And earlier we have large expanse of mangrove, but in many areas the mangroves are being either from natural forces, wave and so on, in being reduced, as well as from human action, because they are cutting this mangrove for firewood and so on. So basically, this is something from our research work, we feel that we need to introduce something else. And with that, we come to what we have been doing in this particular site, and we have other sites that we introduce the same thing. What you can see there is what we have done, right? So basically, you can see that there's a tree line there and rehabilitation site. So basically, what we do is we choose a site that have closer to that site, natural mangrove, which is very thin, just a strip of land that have natural mangrove. And then what we do is we introduce our replantation of mangrove. But before that, we introduce our breakwater, meaning to protect the mangrove that we are going to introduce against wave action. So basically, the tree line that you see above the rehabilitation site is basically the breakwater that we introduce. So historically, the site for the project have undergone several phases of engineering work. For example, in 1977, because of the threat of wave action, they have built dike along that coastline, and with an earth dike, that particular structure, earth dike, will be exposed to wave action. So in 1991, they introduced some maintenance work where they introduced dike about 1.5 kilometer with which is being armored. Meaning they introduced structures to resist or to work against the wave of nature, the wave action. And if we go to the site, we can see that they have done that. But with time, that is also inadequate. And for this study, for this particular work, we have introduced our way of dealing with this particular problem. So basically, with the earlier method, they just simply introduce the protection. But with this method, we try to introduce both. With the number 1, 2, 3 is basically a breakwater, low crested multi-structure was selected as the final design. And behind that, we have introduced the area that we restored by planting suitable mangrove species. And you can see that that is basically the site. And so basically, as a cross section, you can see that on the right side will be the seaward side, and the MHWL is the mean high water level. And on the left side is the agricultural land, and the dike is basically the old structure being constructed. And since it is quite open, it is subjected to further wave action. So between the dike and the open sea, we introduce our approach. That is the two approaches that we mentioned about. One is the breakwater, which is the hard approach. And second, we have introduced suitable species in between the old dike and the breakwater. So basically, we are expecting that will be more natural to protect the agricultural land, where we have the restoration area where we introduce mangrove, and the breakwater is meant to temporarily protect the area that we are going to vegetate with mangroves. So basically, meaning to say we are introducing the hard approach and the soft approach. The hard is the structures, and the soft is the planting of mangroves. The structure is basically designed by us, where we use a very simple approach, which is porous. So basically, this can be called as a simple breakwater. And what we have is, okay, I go back. Okay, at the bottom we introduce bamboo mat, because bamboo is very cheap, easily available, and the idea is to support the load. Because the area is muddy, it means that it is soft. So anything that you introduce which is heavy will will be submerged in the mud. So what we do is we introduce a bamboo mat. Using bamboo, we form a length of a mat. So basically, we then introduce our structure to reduce the wave action, where we have rocks filled in the wire mesh, and the block that you see above there is the L block. So basically, the L block is designed by us in and it has won an award in Geneva. Basically, we use that L block because it is not solid. It has voids, right? It means that when wave struck that area, that breakwater, it doesn't have to take too much force because of it is not solid phase of structure. So basically, this is our design, which is meant to absorb the wave action. At the same time, it is able to sustain the load because of it is not solid in that sense. So it means that water can seep through, and any wave will be dissipated, the energy will be reduced, and that is what we have. So here is what you see on site, the one that we have shown in the diagram. So you can see that on the left are the bamboo being laid below the the heavy structures. Then we have blocks of stone and rocks, and then we have our L block. So if you go back, so basically you can see that the bottom part is the bamboo sitting on a soft muddy deposit, and then we place our rock because we need that rock to provide the support against wave. But the rock, if it is not enclosed, it will be subjected to the wave action and soon it will disintegrate. But we will then enclose the rock with the L block, so that together will form a structure which can support the load, and at the same time it will not break because of the rock is being enclosed by the L block. So meaning it can move, but it will do the work to take the pressure of the waves, and at the same time it can be sustained. It can sustain its form, but it will move a bit. But it doesn't matter because there's no human being who will be staying there, so it doesn't matter. It moves a bit, right? But basically, it do the work of taking the pressure, taking the wave action. So basically, this is our design, and this is what we have on site. We have another one on another side, and both sides shows that it works. So it means that it can be applied anywhere, but it has to be designed according to the characteristic of that particular site. Okay, we mentioned that we are using hard and soft. So the earlier one is the hard approach, and we also introduce mangrove. And here you can see that the mangrove is not planted on its own, but it has it is planted using coil logs, meaning to say there are material that is formed into a logs, and we use many logs, right? And it's made up of coconut material, right? Based from coconut. So basically, it is put together, and it is enclosed in a wrapped string type material. So that can be a basis, will be used to place the seedling of mangrove plant. So basically, it is biodegradable, meaning to say when we put on site, soon after, with some time, then it will be, it will be gone, right? It will disintegrate. So basically, we need that so that the seedling can be established. right? And with that scheme of work, we monitor the area for deformation, for movement, and so on. So basically, this is what that have been done, and based on that, this is what we find out. And I think I haven't mentioned earlier, the purpose of the breakwater is to protect the mangrove. At the same time, it is also being used to raise the level of the area, so that planting of mangroves can happen as we wish. So this is the response for the area from July 2008 to October 2008, meaning to say what we plan to have, that is the raise of ground level behind the 3 breakwater has happened. Okay, so basically you can see that those are the photo of that particular breakwater. Behind the breakwater, you can see that mud is being deposited, meaning to say the ground level is being raised, and the idea is to ensure that it is adequate for mangrove to be established. Okay, so basically this is another slide on the response due to what we have introduced, that is the breakwater, right? So you can see that behind the breakwater, right, closer to the land side, we have deposition of mud, right? And this is expected to be adequate to later on provide basis for mangrove to develop, to grow. And we can see also that on the left hand side, we also get some deposition of mud and soil material, and that can also be used for planting as well as other purposes. As far as the response is concerned, you can see that with time, we can see the increase in the level of earth and mud being deposited behind the breakwater. It means that what we are planning is happening, right? Of course, at that point of time, we cannot predict the rate of deposition because of there's no known formulation or theory on how much will be deposited, right? At what rate? So basically, we are monitoring so that we can see the rate of deposition of this material, and from that we will then introduce suitable species, right? So basically, we are getting what we expect, that is, with time, we will be getting an increase in the ground level, and we also expect with that we will get the necessary hydrologic condition for mangrove to be replanted. Okay, so basically, going back to that similar graph, you can see that with time we get further deposition of sediments, and by this particular time we see that the area behind the breakwater is much higher than the area seaward towards the sea, and that is something that we expected, and we haven't done the analysis to see the rate of growth of sediment because that will be for further work, and the other part of the work will be to introduce breakwater, and this is the L block armoring unit that we developed in UM, right? So this is the first time that it is being tested outside. So when we developed that earlier, we have small model of about 5 cm size of that L block being tested in our hydraulic lab. So basically during that testing, we see that it can work, but basically it is difficult to be sure because of in the lab condition, everything is quite ideal, as well as in lab condition, the actual forces that happen on site cannot be replicated. Meaning to say we cannot truly test the field condition, the condition on site. So basically, this can be said that is the first time that we can introduce and test on site. So basically, we are talking about the armor unit. So you can see on the right hand photos that we introduced that 3-layer L block, and there are several things that we have to consider. For example, the right kind of cement. So, but this is just a trial. So basically, at that point of time, we are not too sure what kind of cement to be used, what kind of concrete grade to be used, and the idea is also to allow for some deformation, some degradation, as long as the form can be retained, because we are not building this for human occupation. For example, if we are building a bungalow, an apartment, then we have to be very particular about the quality of the concrete being used. But here, we are only blocking, or we are only producing something to reduce the energy of the wave. So basically, we can sacrifice some quality. So you can see that if this happened to your column in your house, you will not like it. But basically, it is okay for our purpose here, because it is not meant for human occupation. So this is what we see and we observe on site, and if we go to the site, you can see that the structure is still intact, and it have done its purpose where it is being installed there. For this particular project, right, the overall cost is about 85 USD, which is about less than about 300 something K, 300K. This is for construction, restoration, training, monitoring, and everything, right? So basically, when we plant mangrove, we use about 25 USD, which is about 100,000, and the breakwater is about 40,000 USD per meter length. Okay, so basically, this is what we can see on site, and just to wrap up, we are still doing this particular work, because as we have mentioned that our earlier, what we have shown you is basically a trial, right? We have done it in Sungai Hajrani, as we have seen today. We have another trial in Carey Island. We have similar response, but basically in terms of site, this Kuala Selangor, Haji Durrani is in Kuala Selangor, right? It has muddy ground, muddy deposit. It means that we have problem of if you put something heavy, it will settle a lot, it can go down. But on our second side, it is hard sandy deposit. So basically, we are doing that so that we can see the how best to manage different kind of coastal area. So for both sides, we see that we can manage both sides, either it is soft, muddy beach or sandy area, or we can also manage for harder material. So that is one of our conclusion. it means can be done. Secondly, since it's not for human habitation, not to house people and so on, so we can afford to have a lot of deformation, a lot of settlement and so on, uneven settlement, because the idea is for the structure to be there. It can, it can go down a bit here and there, but it can do the purpose of taking the wave energy. And as you can see from the red arrow, right, if the breakwater is in front of the restored area, or if we have a structure there for whatever purpose, then it can serve to minimize the wave energy, as well as we can use the area behind the breakwater for whatever suitable purpose. In this particular study, we are using that to restore mangrove, but basically we can use the same approach so that we can have, for example, a floating restaurant and so on, meaning for whatever purpose it can be design and construct to keep the purpose. It means that what we have introduced work, right? So basically, the subject of this particular presentation is hard and soft approach, meaning hard engineering, soft engineering, right? So it works and it can be applied, it can be replicated in whatever suitable site for whatever problem. But as of any engineering project, each project have to design accordingly, so that if it needs to be installed somewhere in Perak, we need to just go and establish the local condition, and then we can design accordingly, and we will know how much we need to construct and so on. So just like constructing a house in Klang and in Cameron Highland is different, because Klang will be soft. It means that it has to take more settlement. But in Cameron Highland, maybe it is hard, but you have a problem of slope, right? So meaning to say, what we have approached, what we have established works, but when we want to apply to anywhere, we need to establish the condition of that particular location. But what we introduce will be the same and designed accordingly. So what we have been looking earlier is coastal protection using eco-friendly engineering, meaning to say we see that even though we are building a structure, but that structure is basically can be quite natural to the environment, and we are not blocking anything. Water can seep through. It serves the purpose of protecting the area behind the breakwater. So whatever we want to do with the site behind the breakwater can be implemented. So as far as we see, this is an eco-friendly engineering approach, can be applicable anywhere, but we need to design accordingly for the site condition, for the wave condition, for the ground condition, and we feel that this should be suitable for those who settle along the coastline or who has property along the coastline. So basically, to wrap up, this is what we have done with about 300K. We have managed to establish a pilot project where we introduce protection, and with that we can use whatever the area behind the protected area. We can use that for whatever purpose that we want, but we need to design accordingly. With that, I just would like to say a few of thanks to the Faculty of Engineering and Department of Civil Engineering for supporting the work and the research project, right? Ministry of Higher Education for the grant, FRIM, Forestry Research Institute of Malaysia, for funding part of the project, and UTP for providing facilities for testing, because they have a large flume to test the breakwater model. Our flume is very small, their flume is big. Even though they charge us quite substantially, but still if we don't test there, we do not know how to design accordingly. So basically we acknowledge them for their support, and throughout my research work, these are the people that have been our collaborator, right? So I also would like to acknowledge their contribution, and hopefully our relation for research work can continue so that we can produce more work for UM and for Faculty of Engineering. With that, I thank all of you for listening, and I hope that whatever I have mentioned, whatever said will be useful for people, and maybe we can work forward based on what we have discovered. Thank you very much.
Thank you, Professor IR Dato Dr. Roslan Hashim, for the lecture. Distinguished guests, I would like to call upon Professor IR Dr. Abdul Aziz to conclude the lecture.
Thank you, Dato. That was a very interesting talk. So I think I could follow majority of the items lah. So this morning we hear many things. I think I will just conclude by taking 4 main important points from the talk. So obviously, Dato has done a real impactful application work. So this is one of the very clear proof that whatever that we do in the lab can be directly applied. And I'm sure, Dato, you can relate some of your work with so many lives that you saved during tsunami. Probably later, because we are working in Penang. As we know, Penang was the most affected by tsunami, and I believe coastal protection is one of the most important feature there. So probably after this, Dato can start looking at that lah. Number 2, and this is obviously a multidisciplinary area. Prof. Sumani is smiling at me because she is the what do you call the cluster chief, cluster dean, who's supposed to promote multidisciplinary. Here we can see the biologists involved. I know you're working well with Prof. Pang, right? OES, and many items. This is something that I think we have to take note lah, because you see biologists are involved here, material obviously involved here, and things like that. So I think it is time for us to start believing in multidisciplinary work, especially if you want to make it application based, where majority of our funding are coming for this kind of work now. Yes, fundamental, but you have to think about multidisciplinary and application as well. And number 3, this is also interesting to see how engineers, unlike what many people outside they think it's a very hardcore and things like that, but we also have a soft heart, and looks like we work with the nature. So this main group is basically putting back the nature. We take out the nature either by naturally or artificially, but we put back nature. We try to work with the nature. So I can see the logic of this title, soft and hard engineering. I was thinking earlier, what could that soft be? Working with nature, working with the existing system. So that's one takeaway point as well. And finally, it is also interesting to note that solutions don't have to be a rocket science lah. Yeah? Sometimes simple solutions and imperfect solutions. See, like you correctly mentioned, Dato, you said that the cement blocks don't have to be of high quality, but this is sufficient enough for you to do the job. So this is also another point to take home, that most of the time, good solution not necessarily requires a very high expensive material or expensive system to work. As long as we have the fundamental to go around, it is okay. And finally, I think it is also notable from the slides and the presentation, there's a lot of fundamental that goes behind it. So engineering is also about fundamental. So the dike made, the water break that was developed, all these are based on fundamental, not trial and error basis. There is some fundamental behind it. So I thought that was the major takeaway point from your talk. And obviously, this is only one of the example. I personally know that Dato has worked on few other important projects. That is probably one of the reasons why he got his Dato-ship from Penang. So Dato, good luck with your work. I'm sure you have a lot of things to contribute, not only to the university, but to the nation as well. With this kind of work, I believe this is very useful. So I think after the tsunami incidents, a lot of things are being spoken about coastal management. And not only that, erosion due to a lot of coastal activities. And I believe that you will do much more better after this, and more multidisciplinary work, please. With that, let us give him a very big clap of hand. It's all yours, MC. Thank you very much.
Thank you, Professor IR Dr. Abdul Aziz, for chairing this lecture. I would like to take this opportunity to thank the management of the Faculty of Engineering, International Corporate Relations Office, citizens of University of Malaya, as well as all the guests here for your time. With this, we have reached the end of the lecture. On behalf of the University of Malaya, I would like to apologize if there are any weakness from our side in organizing this lecture. Ladies and gentlemen, once again, thank you and have a pleasant afternoon.